by looking at limits, and this is the basic limit rules. If L is equal to L prime, and L prime are numbers. Of course, as x approaches A, then is equal to L plus or minus L prime. The limit as x approaches A of f times g of x is L times L prime. Let's hope this one stays this time. Nope. Okay. Let me try this one. Nope. Okay, great. And of f of x over g of x is L over L prime provided what? L prime is non-zero. Awesome. And then what do I have as well? Yeah. If g is a constant, is equal to c L prime. C is a constant. What did we see as well? If f of x is a polynomial, then the limit as x approaches A of f of x is equal to f of A, right? Remember that? Just let me check that everything could be, yeah, okay, I think that, okay, great. Awesome. So, now let's add one more. If n is an integer, is a positive integer, then the limit as x approaches, because I use f here. H of x is a polynomial, I'll just replace f by h. Doesn't matter. Then the limit as x approaches a of square root of the nth root of f of x to the n is the nth root of L. Here, of course, the nth root of L needs to be defined, right? Yeah, so if L is 0 and n is even, you need f of x to be slightly positive in a region containing A, right? Okay? So basically, we have to pay attention to n and the sign of n. Attention to the parity of n and okay? I mean, there will be no traps here, okay? So I will not give you the limit of the square root of -1. I will not give you that, okay? Awesome. Great. Parity, like even odd, right? Parity is even or odd, right? The square root, can I put a negative number inside the square root? No, okay? Fourth root, I cannot, okay? Yes?
For the top one, you put C times F of X.
Oh, C times L prime. C times L, not L prime. This one? Is that what you meant?
Yeah.
There's no L prime, it's L. Thank you. Okay, oops. Okay, great, awesome. Any questions so far? Any questions? Great, awesome. Let's continue. Guys, any questions? Yeah.
Sorry, I didn't catch what parity means.
Parity is even or odd.
So like how?
Okay, so if I tell you that the limit as x approaches 5 of f of x is -1.
Yeah.
And n is 2, do you have the square root of -1?
Oh,
Okay? So there will be no traps here. So if n is even,
yeah.
L needs to be, and L is strictly positive, it works.
Okay.
If n is even and f of x is positive or 0, then it also, and L is 0, then it also works. Okay?
If it was odd, then it could be negative.
If n is odd, you could put anything.
Yeah.
The cube root of -1 is -1. Okay? Is that good?
Yeah.
Great. Yeah? May I help you? Yeah? No? It's good? Okay, great. Now let's do an example, or an important example, or if oh, I forgot one as well. I forgot one. The limit as x approaches a of f of x to the n is L to the n, okay? Okay. And limit what is that? F of x plus 2g of x, what is this limit? 3 plus 2 times 4, what is that? 3 plus 8, which is 11, right? From here. Root f of x over g of x squared. What is this limit? F of x goes to 3, right? So root f of x goes to f of x goes to 3. Root f of x goes to root 3, right? G of x goes to 4, so g of x squared goes to, are we good? Is that clear? Awesome. Great. Enough time to think about that. Now another theorem. Of course, I will not repeat this again. F and G are assumed to be defined on an open interval containing A, except that possibly A itself, okay? I'm assuming that we can talk about the limit, okay? So I will not repeat that. So if f of x is equal to g of x for all x different than A, okay, then g of x, provided the limit exists. Okay, so they either both exist, both limits either both exist and they're equal, or both do not exist. Okay, now let's do a small example of this, an application of that theorem. Example. If I give you f of x equal to x over x, what is the domain of this function? Everybody, what is the domain of this function? X over x. All x except 0. Defined for all x different than 0. Now, if x is different than 0, what is f of x equal to? X is different than 0, so f of x is equal to 1. If x is different than 0, f of x is equal to 1. Now, how do I sketch the curve of f? It's the curve of 1, right? The line y equal 1. But at x equals 0, I have a open circle, right? I have a how do you sketch that curve? This is the line y equal 1. F is not defined here. And this is the curve y equal f of x. You agree or not? What is the limit as x approaches 0 of f of x? One, right? It's equal. Well, f of x, if x is different, if x is approaching 0, can x be equal to 0? No. So if x is approaching 0, then x is different than 0. Then f of x is equal to 1. You agree or not? which is equal to, oops. Clear? Is it clear? Are we good? Now notice, if you want to try to plug in numerator and denominator, what do you get on the numerator? Just on this formula above. 0. What do you get in the denominator? 0 over 0. Now, did we see any law concerning 0 over 0? In the limit law, did we see any law concerning 0 over 0? No. Okay. Now, notice that if you put a 2 here, just 2x over x, and you plug in, what do you get? 0 over 0. But what do you get as the limit? If you put 2x instead of x here, 2x. 2. You agree? So 0 over 0 gave you 1 in one case, and 0 over 0 gave you 2 in another case. You agree or not? If you put 2x here, the limit 2x over x, what is that? First of all, what do you try to do? You try to plug in, right? Limit of 2x is 0, and limit of the bottom is 0, right? 0 over 0. Now, of course, you don't need to plug in here. I mean, you can just cancel, right? What do you get? You get, 2 is equal to 2. So 0 over 0, can I really determine what it is, or it could be anything? You agree with this or not? Everybody. So say if you put like 20,000 x over x, what's the limit? 20,000. But it's still 0 over 0. You agree? Okay, last time we saw that 1 over a 0 that is positive is plus infinity. You remember this? 1 over 0 that is negative, it's negative infinity. But 0 over 0, can I determine what that is in the sense of limits? No. So what do we call it? We call it an indeterminate form. Okay? Zero over 0 in the sense of limits, in the context of limits, is indeterminate. It could really give you anything. It may give you something that doesn't exist as well. Okay? Everybody, we're good? Okay, now, enough said. Let's move on to examples. So who wants to volunteer for their favorite number? You raise your hand, yeah? 2. Okay, thank you. Okay, guys. Find the limit if it exists. The limit as x approaches 2 of x squared minus 3x plus 2 over x minus 2. Are we good? I'm kind of ignoring this side. Are we good on this side? Yeah? Okay. Just stretching? Okay. Great. Okay. Now, what's the first thing I try when I have to evaluate this limit? What's the first thing you do? You want to try to use the limit laws, right? What do? I have a polynomial on top, polynomial on the bottom. So I can try to plug in. Plug in 2 here, what do you get? 2 squared, which is 4 minus 6 plus 2. 0. On the bottom, what do you get? 2 minus 2, which is 0. This is 0 over 0. Can I determine what this is? No. Great. Now, what do you suggest doing? I factor the top. Very good. How do I factor the top? What is a root? 1 is a root, and 2 is a root, right? You see that? It factors as x minus 1 times x minus 2. divided by x minus 2. We agree or not? Now, when x is going to 2, can x be equal to 2? No. So what can I do with the x minus 2? I can cancel out. I can cancel them out. Really, what is the thing that is making my form indeterminate? What is the thing that's giving me the 0? On the bottom, it's x minus 2. You agree? On the top, is the x minus 1 giving me the 0? It's the x minus 2. So what I really want to do is to get rid, if possible, of the factors that are, or the terms that are giving me this indeterminate form. Okay? So let me factor this out. What do I get? I get x minus 1. I'm just canceling them out. And what do I get? Can I plug in here? I got 1. Are we all good here? So far, are we all good? Any questions? Any questions? We good? Yeah. Great. Should we do one more? Let's do one more. Who volunteers for a number? Raise your hand, yeah, in the back. Yeah? 5? Okay, let's go for 5. Let's go for 5. Oops. 1 over x minus 1 over 5 over x minus 5. What's the first thing I try? I try to plug in. I have a quotient. I try to plug in on top. What do I get on top? 1 over 5 minus, that's 0. On the bottom, what do I get? 0. So, what form do I have? 0 over, do I have any rule for this? No, it's an indeterminate form, okay? Let's remember this name, did I write it down? Indeterminate. 0 over 0. Great. Now, what can I do? These are not nice polynomials, right? 1 over x is not a polynomial. You agree? Now, how can I deal with this? Yeah, yeah.
Can I write up and down?
I can?
Derive x minus 1 over x squared over 1.
Sure, but we did not see that yet. So let's try to stick to what we know. Yes?
You can get all the denominators for your polynomial.
Exactly. Well, these are not polynomials, but yeah, very good. So put everything on a common denominator. Very good. Yeah, so I multiply this one by 5, right? I have 5 over 5x, and I multiply this one by x over x minus 5. So, yeah, now some of you, who has seen L'Hopital's rule? Okay, so maybe many of you will want to use L'Hopital's rule. Now, if you use it without proving it, before we see it in class, it's a straight 0, like straight 0, okay? So please do not use L'Hopital's rule before we see it in class. Or you have to prove it, okay? And the proof, you know, I have some trouble remembering the proof of L'Hopital's rule, so it's not an easy proof. It's not bad, but okay? So again, you have to stick to the knowledge we see in class and not resort to any type of methods of solving the question that you have seen wherever, CJF, high school. Okay, great. Now what can I do? How can I continue this? So yeah? Sure. So let me first collect them. Limit as x approaches 5. 5 minus x divided by 5x divided by x minus 5. Yeah, so your friend suggested I want to cancel. What do you want to cancel here?
The 5 minus.
And the x minus 5. But what do I have to put in? A minus 1. Exactly. You agree that if I want to cancel 5 minus x and x minus 5, what is left is a minus 1. We agree or not? Yeah? It's minus 1 over 5x. Can you plug in now or not? Did you get rid of the thing that's giving you the 0 or not? You got rid of the 5 minus x. Okay, and then this is minus 1 over 25. All good so far? All good? Questions? Yeah? Okay. Yeah? If you multiply the top and the bottom by x plus 5, so you want to multiply here by x plus 5? Okay, and then what do you do? Well, so you get x squared minus 25, and then you get, so you get 25 minus x squared minus 25. Right? It's the same thing, right? Why would you multiply that? Right? You see what I'm saying? You can just cancel them. Okay? Mathematically it's correct, right? Okay. So far so good? Everybody? Are we good? Let's look at more examples. I will keep this term indeterminate for. Okay, guys. I want someone to volunteer for a number. Just one second. Who wants to volunteer for a number? Someone from this side. Yes. 7. The limit as t guys, please. Guys, hey. The limit as t approaches 2 of square root of 7 plus t. Okay, this is your number. 7 minus 3 over t minus 2. You know what? Let's change a bit. Sorry about that. T squared minus 4. Okay? Yeah, awesome. First thing, what do? I try to plug in. On top, what do I get? 7, so t, I can plug in. 7 plus t is a polynomial. Do you agree? So when t is 2, what is 7 plus t? The limit? 9. So root of 9 is equal to 3. 3 minus 3 is 0. On the bottom, 2 squared minus 4 is 0. So what do I get? 0 over. Can I determine what this is, or I have to work it out? I have to work it out. Great. Now. Yeah.
What is the meaning here of like indeterminate? So you're not supposed to just like plug in the limit?
Would you?
So did you say I think like one of the factors because it's never just plug in the limit and like try to approach it like avoid mistakes like this?
Pardon me?
Like don't plug in the limit directly into the equation. Just like
No, I did not say not plug in.
okay.
I said like it doesn't always work.
Oh.
Okay? Don't just plug in. I mean, the results we've proven, the limit laws that we've proven, allows you to plug in, right? F of t is a polynomial, so you can plug in that case. Roots, you can take a root of a polynomial, right? What I was saying that you cannot just say for any function f that this is true. Okay? If f is a polynomial, then you're good. Then this is true. Okay? Is that clear?
Yeah.
Great. Now. Yep. Oh, you want to help? Yeah, please.
Multiply by the conjugate.
Multiply by the conjugate, that's a nice word, but what's the conjugate?
Or is that the denominator? Or is that, or sorry, I had like 7 plus t plus 3.
Exactly. Did we see that? Did we ever see this? Yeah? So, root 7 plus t minus 3. I have a t squared minus 4 here. And then your friend suggested that I multiply by square root of 7 plus t plus 3. Of course, if I multiply on top by square root of 7 plus t plus 3, what do I have to do? I have to also multiply it on the bottom. All agree with this? Yeah. Great. Okay. Now, why did we do this? Yeah. Could you please say it? Difference of squares. Great. And then why? I can cancel what's it? The square root, right? Yes. Is that what you want to say? Yeah. What is a minus b times a plus b? I don't know what you call this. This is just a squared minus b squared. Do you agree? Now if I apply a to be square root of 7 plus t and b to be 3, what do I get? That's what I have. I have a minus b times a plus b. We agree or not? So what is a squared here? A squared is 7 plus b, and b squared is 9, right? b is 3, sorry. And b squared is 9. Do you agree or not? Everybody, do we agree? Yeah, do you have a question?
When you actually multiply it out, it's negative 9, right? Negative 3 positive is maybe.
Yeah, b squared.
But b squared is a.
Yeah, okay. A squared minus b squared is, yeah. So 7 plus t over 9, what do I get? We all agree with this? If you're not convinced, what do you have to do? Just expand. If you're not convinced, what do you do? Just expand. Multiply these two, 7 plus t square root 7 plus t minus 3 square root 7 plus t. What happens to these two terms? They cancel out. Minus 9. That's what you get. Okay? Are we good? Everybody, are we good? Here. Any questions? Any questions? Okay, let's do this here. Limit t, so I get t7 plus t minus 9 over t squared minus 4. Any questions? Got any questions? Any questions? I had to multiply the bottom by the square root. Yes, I forgot that. Thank you. Great, thank you. I wrote it here. Okay, great. Now what do I have? I plug in again. What do I get? I really didn't do anything now, right? I just multiplied. I made things nice. But did I get rid of the 0 over 0? Plug in on top. What do you get? 0. Plug in on the bottom? 0. Now is this term giving you trouble? No. So you stay away from it, right? It's not giving you trouble. Don't try to expand. What is this term? 3 plus 3, right? 6. We agree? Is it giving you any problem? No. So you keep it. You don't touch it. Okay? Now, what's the term that's giving me trouble? T minus 2 on top and t squared minus 4 on the bottom. Who can help? Someone who hasn't spoken today? Yes?
Expand it. So t minus 2 is equal to, and then cancel out.
Exactly. Thank you. So, your friend suggested that you meant factor it, right? You meant factor it, right? Oh. You meant factor it. Yeah. So t minus 2 over t plus 2 times the square root of 7 plus t plus 3. Sorry about the handwriting. I just don't have a lot of space. And then what do you get? You cancel out the t minus 2. Let me rewrite. This is limit t goes to 2. T minus 2 over t minus 2. Guys, please. Hey, please. Okay, what can I cancel out? The t minus 2. Did I get rid of everything that's giving me 0 over 0?
Yeah.
Can I just plug in now at the end?
Yeah.
Very good. What do I get? Who wants to finish it? Yeah? 1 over? Let's try that. So 1, t goes to 2, so it's 2 plus 2, right? And then times 6. Wait, what? Is that good? 1 over. Yeah, is that good? Yeah. Awesome. Thank you. Okay, what time is it? Oh, whoa, we still have like 10 minutes. Okay, 12. Are we all good with this? Guys, please. Any questions? Okay, hey, guys, are we all good? Please, it's year 400, right? So if everybody talks a little bit, it's gonna make a huge noise. Okay? Any questions? Okay, yes, sir. Sure, you want to do an example where you can't plug in? We will see that or you know, let's do something like that. Sure. I mean, it's a nice example. Thank you for the question. Okay, can you see on this side? You cannot see, okay, so this, yeah. Okay, let me write it down here. Okay, let's do this one here. Okay, guys, hey, if x is different than 0, f of x is x over x, and give me your favorite number. 6, if x is equal to 0. Okay? You agree? Great. So really, this is the graph of my function. Here, right? Now, what is the limit as x approaches 0 of f of x? We have established that it's equal to 1. Right? What is f of 0? Is equal to 6. Can you just plug in here 0 for f? No. Is that good? Is that clear? Okay. Is that clear, everybody? You cannot just write f of 0 for any function f. If f is a polynomial, then you're good. Okay? Okay, great. Questions? No? Okay. Let's move on to more difficult examples. Yeah, I'll try to avoid writing here. You have a question? Yes? What was the graph of this one? This is the graph. Yeah, this is the point 0.06. Okay? Any questions? No? Great. What are we going to do? Let's do some... do we like absolute values or not? Let's... Unfortunately, they will appear many times. Okay. Okay, who volunteers for their favorite number? Oh, okay. Nobody wants here on this side, favorite number? Yes, sir. Yeah? 11. Okay. Let's see. I want to say something. Okay. Plus is x minus 11, so that's x squared minus 12x plus 11. X minus 11. In absolute value. Yes, guys, A. 11. Denominator is 11, 11, 11. Doesn't look like 11. Okay. Are we all good here? Okay. Now, if you expect a number to be close to 0, a number approaching 0, its absolute value, what would it be? So right? If you have a number that is approaching 0, either negative or positive or any way you want, its absolute value will approach what number? 0. You agree with this or not? Okay. So on the top, what do I have here? On the top, I have a polynomial. If I have to evaluate this limit, what do I have to do? I have to plug it in. So 11 squared minus 12 times 11 plus 11, what is that? That's 0, right? You guys see this or not? Did you calculate it? Did you calculate it or not? But it's 11 squared, how do you do that? 11 squared is 11 times 11, right? 11 times 11 plus 11, how many times 11? 12 times 11. Minus 12x, 12 times 11 is 0, okay? So you have 0 over 0. But I have to get rid of the absolute value here. Yeah? Exactly. Well, exactly. So if x is approaching 11 plus, what can I say about x? Is it strictly bigger than 11 or smaller than 11? Strictly bigger than 11. So as x approaches, what can I say about x minus 11? It's positive or negative? Positive. X minus 11 is positive. So what is the absolute value of x minus 11? Is equal to itself. You agree or not? Everybody, do we agree or not? Yeah. Okay. On top, what can I do on top? I can factor it. Yeah. You want to help? How do I factor it? Yeah. X minus 11 times x minus 1. Thank you. And then on the bottom, since I have established that x minus 11 is positive, then the absolute value of x minus 11 is equal to x minus 11. Then I can write. Okay. Then what do? I can cancel the x minus 11 out. And then what do I get? The limit as x approaches 11 plus of x minus 1. What is that equal to? 10. Are we good here? Yeah? Okay. What time is it? 20? Yes, sir.
What's an example in which the absolute value of
Sure. Very good question. What's your favorite number? 8. 8. Great. Do we know the? Okay, maybe it's a good thing to we can refresh our minds. Do we know our memory? Do we know long division? Okay, that's good. Maybe we. Okay, let's evaluate this limit. Limit as x approaches 2 minus of x minus 2 over x cubed minus 8. First of all, what's the first thing I try? I try to plug in. We agree? On top, what do I get? 0. On the bottom, x cubed minus 8, it's a polynomial. I can plug in 2. What do I get? 2 cubed minus 8, which is 0. Now, in absolute value, right, it's also 0. So I get 0 over 0. The first thing I've got to do here is what? Is to try to remove the absolute value. We agree or not? Okay. Now, x is approaching 2 minus. So x is smaller than 2 or bigger than 2? Smaller than 2. So if x is smaller than 2, what can you say about x cubed minus 8? X cubed minus 8 is what? Negative or positive? Negative, right? You agree with this? If x is approaching 2 minus, then x is strictly less than 2. You agree? So x cubed is strictly less than 8. You agree or not? So x cubed minus 8 in absolute value, well, x cubed minus 8 is negative. Let me write this one here. X cubed minus 8 is negative. So if x cubed minus 8 is negative, what is the absolute value of x cubed minus 8? It's minus x cubed minus 8, right? You agree or not? Yes? Everybody, do we agree? Okay, awesome. Let me go back to my limits. So, limit as x approaches 2 minus of x minus 2 over x cubed minus 8. What's the first thing I did here? I got rid of the absolute value, and I have a quotient of 2 polynomials. I'll just add minus x cubed minus 8, okay? You can write as 8 minus x cubed, that's also fine. Okay? We all agree with this? Yeah? Okay, awesome. Now, you try to plug in, you get 0 over 0. I mean, you really didn't do anything, right? You just got rid of the absolute value. Well, that's something, but you did not get rid of the 0 over 0. Now, how do I approach this? Yes? Difference of cube, okay. Have you all seen difference of cubes? Yes. Did we see difference of cubes? Yes. Everybody? No. Okay. Okay. Yeah. Because I did not see difference. I mean, I still don't know the formula by heart, so like I have to. So what is it? A cubed minus b cubed is a minus b times a squared plus ab plus b squared, right? Yeah. Okay, we can do that, or we can do long division. Notice that, guys, hey, when you plug in 2 here, what do you get? 8 minus 8, which is 0. So you know that x cubed minus 8 is divisible by x minus 2. You agree? I mean, how do you do that? You do this way? I mean, there are many ways of doing it. Is that how you do it? Yeah? So what do you have to multiply by x to get rid of the x cubed? X squared. X squared. So x squared, well, let me put the minus 8 there. So x squared, so you get x cubed. And then minus 2x squared, right? What do you get? You get 2x squared minus 8, right? Agree or not? Yeah? Now, what do you have here? What do you have to multiply 2x, x to get rid of the 2x squared? 2x, right? Plus 2x. So you get 2x minus 4. Wait, what? Is that? No, so you get 2x minus 4x. So you get 2x squared minus 4x. And then you get 4x minus 8. And then what do you have to multiply x minus 2 to get 4x minus 8? 4, right? So x cubed minus 8 is x minus 2. Okay, now what do? You you cancel out the x minus 2, and you plug in. You have a minus here, minus 2 squared plus minus 4 plus 4 plus 4, right? So you get minus 1 over 2. Okay? Thank you.